Chapter 17, Section 2, Reaction Rate. If you remember from Section 1, reaction rate means speed of reaction. And if you remember, for a reaction to occur, there are two conditions. Particles must be collide with enough energy. So the first one, collision with enough energy. And the second one, particles must be collide in correct orientation. So the second condition, correct orientation. So any factors that affect these conditions will affect the rate of reactions. So what are the factors that affect the reaction rate? So here, factors that affect the rate of reaction. The first factor is nature of substance. You have to know that it depends on state of matter, bond type, and bond strength. So what about state of matter? How state of matter affect the rate of reactions? So now state of matter gas particles react faster than liquid and solid particles. So the rate of reaction of gas particles greater than liquid particles greater than solid particles. So why? Because gas particles are free to move. So number of collisions between gas particles increases. So here number of collisions increases. As number of collision increases, so the rate of reaction increases. So here rate of reaction increases. Now what about solid particles? So here solid particles are closely packed to each other. So energy is used to break the bond between them or to separate particles from each other. So energy is used to separate particles from each other. So the reaction occurs. Because energy is used first to separate particles from each other, then the reaction occurs. So the rate of reaction decreases. Here, particles already, they are free to move. They are far apart from each other, so they collide with each other, and as a result of collision, reaction occurs. So the rate of reaction increases. But here, particles are closely packed together, so energy is used to separate particles from each other, then the reaction occurs. Here, direct, the reaction occurs because already they are far apart from each other. So, according to state of matter, gas particles react faster than liquid and solid particles, so the rate of reaction for gases greater than liquid and greater than solid. Now, what about the second one, bond type? So now here, bond type. So the rate of reaction for ionic compound greater than the rate of reaction for covalent compound. Why? Because ionic compound are dissociate to ions in aqueous solutions, and then the reaction occurs. But here in covalent bond, energy is used to break the bonds, then the reaction occurs. So ionic compound has greater rate of reactions, so greater rate of reactions. Why? Again, because ionic compound direct ions compound dissociate to ions in aqueous solution, then the reaction occurs. But here energy is used to break the bonds first, then the reaction occurs. An example, if you have carbon monoxide plus oxygen to produce carbon dioxide gas. So here you have to balance the equation. So first here you have to break the bond between carbon monoxide and the bond between oxygen molecule, then the reaction occurs. But in ionic compound, for example, silver nitrate plus sodium chloride. Here, direct silver nitrate, when dissolved in water, it dissociates to silver ion and nitrate ion. And sodium chloride, when dissolved in water, dissociates to sodium ion and chloride ion. So the reaction occurs. Sodium reacts with nitrate to produce sodium nitrate, and chloride reacts with silver to produce silver chloride. Again, in ionic compound, compounds dissociate to ions in aqueous solutions, so the reaction occurs faster than in covalent compound, because in covalent compound energy first used to break the bonds, then the reaction occurs. So here, if you have covalent compound, the rate of reaction is slow, and if you have ionic compound, the rate of reaction is fast. So the second condition, bond type. So the rate of reaction for ionic compound greater than covalent compound. Now, the third one here, state of matter, bond type, and bond strength. So here, bond strength. So, compound of weak bonds need less energy to break the bonds, so faster rate. But compounds of strong bonds need more energy to break the bonds, so slower rate. So again, compounds of weak bonds need less energy to break the bonds, so the reaction occurs, so it has faster rate. But compound with a strong bond needs more energy to break the bonds, so it has a slower rate. An example, if you have C2H6 plus O2, and if you have C2H4 and O2. Here it has single bond between carbon molecules, and here double bond between carbon molecules. As you know, single covalent bond is weaker than double covalent bond. So in this case, need less energy to break the bond. Less energy to break the bond, so the reaction occurs. But here, double bond is stronger than single bond, so it needs more energy to break the bond, then the reaction occurs. So compounds with weak bonds have faster rate, and compound with strong bonds has slower rate. So here, for the first condition, nature of substance, it depends on the state of matter. So gas, the rate of gas greater than liquid, and liquid greater than solid. According to bond type, the rate of ionic bond greater than the rate of covalent bond. According to bond strength, the rate of weak bonds greater than the rate of strong bonds. Because here in solid or in covalent compound or compound with a strong bond, all of these need more energy, then the reaction occurs. But here in gas or ionic compound or weak bonds, they need less energy, so the reaction occurs faster. Now, what about the second condition? So the first one, nature of substance. The second one is temperature. What is the effect of temperature on the rate of reactions? As temperature increases, kinetic energy of particles increases, so energy of collision increases, so the rate of reaction increases. So again, as temperature increases, kinetic energy of particles increases, so energy produced from a collision increases because they have greater kinetic energy, so the rate of reaction increases. So here again, any factors affect these conditions will affect the rate of reaction. So here the first one, collision with enough energy. So as temperature increases, the collision between particles increases and the energy produced from the collision increases, so the rate of reactions increases.